it is what are referred to as the boundary point. Okay? It's where the solution begins. Okay? And then the solution is actually greater than or less than, in this case less than, this boundary point. So the solution is where this number you get is where the solution begins. Here with an equation, it's the solution. Here it's just the boundary point of your solution. So this is, let's put this on a graph. So how do we, now is 3 a good solution? No. In this case, the boundary point is 3, but it's not included. How are we going to show that on a graph?
Open circle.
Now that's where a lot of people, so I'm going to do that first because that's where a lot of people learn it first. This is not a method I'm going to continue using. You're going to be using an interval notation instead of open and closed circles. But I'll go ahead and mark it that way because it's how you're used to seeing it, and then I'll show you the way we are going to be using it. That means that you put that right over the 3. The fact that it's an open circle means 3 is where we start, but it's not included. Now that inequality symbol will tell us which way we're going on the number line. For some people it's really obvious, like less than and greater than. For some people it's really hard to remember which way it goes. Like I'm a little directionally dyslexic. I always have to think about my lefts and rights and the less than and greater than. So if you're in that boat, don't feel bad about it. It's just brains work differently. Okay? I always equate this inequality symbol with the arrow on a number line. Okay? Meaning this is going down the number line to the left here. Okay? So our solution is everything less than 3, and because of the open circle on 3, it doesn't include 3. Okay. Okay. Now let's go ahead with this one, and then I'm going to show you about the way to write it in interval notation instead. So solving this one the same way, subtract 5 from both sides. Divide both sides by 3. And again, because this is an inequality, you just found not the solution, but the boundary point of the solution, where the solution begins. Okay, so it begins on 3. What do I mark on 3? Yeah, exactly, because this or equal to part of the inequality means that 3 is part of the solution. It is true that 3 times 3 is just 9 plus 15, that's 14. 14 is greater than or equal to 14. Okay? So, as you've classically seen, it is marked with a closed circle. 3 is included, but unlike in the equation, everything greater than it is also included in this case. Going up the number line towards infinity. In fact, let me go ahead and mark that on here. When you're going down the number line, you're going towards negative infinity, and up the number line, you're going to infinity. Hopefully, this is coming back. It's related to back from chapter 8, working with the domain. You know, what are all the x values that could be included? Okay. All right. So the open and closed circle may have been how these are initially taught to a lot of students. But hopefully now you'll recall what we were doing with domain and functions in chapter 8, and we're going to be writing this instead in interval notation. So when you have your number line, instead of an open circle, if you've got the less than or greater than with no equal to, you're going to put a parenthesis. Please put that parenthesis right on the 3. Don't think you have to put it before the 3. Okay? The fact that it's a parenthesis tells us that 3 is not included. Okay? There's no way to the naked eye you can put it close enough to the 3 but not be on 3. I mean, there's just infinite numbers before 3. So don't try and fix that with the naked eye. It's not possible. Putting the parenthesis there instead of the open circle or parenthesis tells you 3 is not included. And of course it still goes down the number line. Also, please draw right on the line. A lot of students seem to want to draw the line above it like it's hovering. No, draw it right on the line. Okay? It just looks neater that way. It's otherwise hovering. It's kind of, you're committing to that number line. Now, your interval notation is written from least to greatest. Okay? So unlike with set notation, which is just a list of solutions, 1 or 2 or 3 solutions, which don't have to be in any particular order. Okay, it looks nice to the brain, but the set notation is an unordered list. It doesn't require anything be in order because it doesn't include the in-between numbers. Interval notation includes the in-between numbers. It wants to know your starting place and your ending place. And your solution is everything in between. So you always go smallest, comma, biggest. What is the smallest value that this solution contains? Right. So we start with negative infinity. If you're using negative infinity, it will always be the leftmost value. You'd never have negative infinity over on the right. Smallest possibility is negative infinity. Now we use a soft parenthesis because negative infinity is not an actual number. You never get there. Okay? So in that sense, it's not included because you never reach it. It's a journey. You're just going in that direction. Comma, so it's the smallest value, and what's the largest value? 3. And 3 is not included, so just like on the graph, we show that with the parenthesis. All right, so do the number line with interval notation and the pure interval notation for this one. Smallest possible value.
3.
And 3 is included. 3 will make the solution good. And the biggest possible value. If infinity is part of your solution, it will always be the rightmost value. You never see regular positive infinity on the left. It's always either the smallest if it's negative or the biggest if it's positive. Okay. Good? Okay. Did I hear snoring? Sheldon! Sheldon! Psst! Wow, he's out. David. Sheldon. Wouldn't bother me if there wasn't snoring. You're snoring. Sorry to bore. But... Okay, so the interval notation we're going to be using moving forward. Set notation used for equalities. Interval notation will be used for our inequalities. Now, interval notation is always the smallest value, comma, the biggest value. And you might be using 2 parentheses or 2 brackets or a mix. So I'll just put one of each here. But the idea is with interval notation, it's smallest, biggest, and this means your solution is everything in between. Okay. So your solution, it's not just a list of random integers, it's your solution is everything in between. Okay. Oh, there we go. Okay, so your basic setup looks like this. There's 4 possibilities. If you have x less than a number, we'll call that number c. Okay. So wherever that is on the number line will be a soft parenthesis and pointing down the number line, and an interval notation is negative infinity, comma, c. And of course the same idea for these are the 4 possibilities. Greater than means whatever that number is, not included, so we use the soft parenthesis and it's going up the number line. Therefore, the smallest value is c and the largest one is infinity. Here, c is included. It's going down towards negative infinity. That's the smallest value. And comes up to and includes the boundary point of c. So the smallest value is negative infinity, and it goes up to c, which is included. Always point your parenthesis or your bracket in the direction that it's going. Make sure you're putting that parenthesis or bracket right on the number. The parenthesis or bracket will tell you whether it's included or not, and draw right on the line. Smallest value here is c, and it goes up to infinity. Now, vocabulary-wise, because you're going to see the first part of the homework is going to ask you to change an inequality statement to interval notation and vice versa. So when you first solve and you get this answer, x is greater than or less than, etc., a number, then this is what's known as an inequality statement. And of course, this is its graph. And this is written in interval notation. Now, a graph can be done either with open and closed circles or with interval notation. For our purposes moving forward, we're going to use only interval notation. So it's a graph here in interval notation, and it's related just pure interval notation lifted off the graph. Let me just add up here. I'm going to slide up here because just to be consistent. So that was the solution. You have one solution in set notation. Here, this is not the solution. It's the boundary point, and you have infinite solutions. Therefore, you must use interval notation because you can't possibly list infinite solutions. Okay? All right. So here's the process, the basic process for solving your linear inequalities, and then we will turn it loose on some more complex problems. Okay. So solve linear inequalities. And again, this is 2.9. Checking back in your book. Technically, if you took 308, this is a review topic from 308, but we're going to be building on it with new materials, compound inequalities, and also absolute value inequalities before we end the semester. All right, so to solve these linear inequalities, you are going to use your general strategy. And the general strategy for solving linear equations. Okay? With two exceptions, I'm about to show you the general strategy. What you already know how to do with linear equations is what you're doing with linear inequalities. Okay? So basically, you kill any fractions or decimals. Okay? You kill any, then, second, order matters here. You kill any parentheses, you distribute parentheses, and combine any like terms. Remember, never cross your equal sign, or in this case, your inequality, without combining your like terms first. And then finally, you are using your addition and multiplication property. Properties. Okay? Add and subtract the same thing to both sides. Divide away the coefficient. Okay? That's already what you're using for linear equations. So general strategy, like with your linear equations. Okay. Now, there's two exceptions to this general strategy. One of them is mathematically required, and the other one is strongly suggested. Not required, but I see students who don't follow this suggested one end up making careless mistakes. It really confuses things. So first, the required one, absolutely required, is this idea. The one deviation from the general strategy for linear equations that we have with inequalities is this. Go ahead and do this. If we had 3x is greater than 12. So go ahead and finish solving that for x. Good? Now, just as let's show about using the test button for checking this. Okay. So if I decide our solution is 4, we're still going to store it the same way. 4, and then the store button above the on key, and X, and push enter. Okay. And now enter your original inequality just like you see it, and then you'll look for a true false. So I would enter 3X, and then go to second math to get my test menu, and I want to choose the greater than symbol, which is number 3. I can scroll down and push enter, or I can just push the number 3 and it will choose it. And then put in 12. And you're going to get a true or a false. Wait, what? What did I do? That doesn't make any sense. Hold up. Did anybody see what I did? Because I'm not sure yet. So if you see, speak up, because something went wrong. Okay. That is the greater than symbol. X must be greater than 4. Because if it's 4, it's equal to 12. If it's 5, it's greater than 12. I'm not sure. Let me see. Let me try one more time. 4 stored in X.
I heard the same.
That it gave a false statement?
Mm-hmm.
Okay. And then 3X, second math, greater than.
Isn't it because 12, if 3 times 4 equals 12, and you're looking for greater than 12, so as soon as...
Right, but because I used the greater than symbol,
then it's looking for everything.
it's looking for above it.
So
Yeah.
that's why it's not... Because it's not equal to 12, it's greater than 12. So.
Yes, but all I'm saying is that 4, I'm saying, we're saying here with the store button, is we're saying X stands for 4. Not that X equals 4. Yeah. So 3 times 4 greater than 12. Oh, wait, but it's the greater than symbol, so it should be okay. Oh, yeah, I see what you're saying. Yes. Yes. How did I get around that before? Yeah. So that's, yeah.
Pretty sure if you put like 5.
Right. I'm trying to think that I've used this button before so that, it'll test if it's right, whether it's greater than or equal to or not. So, you know what, let me think on that and make sure that I don't confuse more when I'm trying to remember what, because I don't use this very often, so I think there's a way around that. Let me get that clarified when I'm, well, let's move on, and I will clarify either on Tuesday, or I'll send y'all an email about checking it. Because that shouldn't happen, and there's a workaround for that, but that makes sense what you're saying. So, anyway, this one we can easily plug in mentally, and we'll go over more about checking your work next week when I kind of straighten that out. All right, so yes, 4 of course doesn't work because it's a greater than. So if we have 5, for example, that's greater than 4. 3 times 5, 15, greater than 12. Check. If we use like X is 0, which is less than 4, so we have 0 greater than 12, which is false. Okay? So you can see, you start to see anything greater than 4, so this is true. This is a good solution. Okay. All right, now do negative 3x greater than 12. Exactly. Now, if you just do it just like this, you do the division just like you would your general strategy with an equation, and you just keep the same symbol. You get x greater than negative 4. Well, one number greater than negative 4, an easy number greater than negative 4 is 0, right? Okay. So negative 3 times 0 is 0. And is 0 greater than 12? No. Okay, well, what about a number that's less than negative 4, like say negative 10? Well, negative 3 times negative 10 is, careful, negative 3 times negative 10. Positive 30, is that greater than 12? Yeah, so it turns out that something greater than negative 4 made it false, but something less than negative 4 made it true. Okay, so this statement is false. And the one difference between this one and this one is what? Yeah, but the negative sign where? In front of the x, the coefficient of x. It doesn't matter whether this number is positive or negative. The one difference in this rule, the variation in this rule, has nothing to do with whether your answer is positive or negative, whether your constant is positive or negative, makes no difference. Okay? All that matters is that negative coefficient. So if you have negative 3x greater than 12, if you are going to be dividing by a negative coefficient, then you must flip the direction of the symbol. Okay? Now I'm going to be really distinct about when I'm talking about sign, I'm talking about positive and negative. I'm talking about the symbol, we're talking about the inequality. Because you're not flipping any signs. You're not changing anything from positive to negative or vice versa. It doesn't matter whether your solution is positive or negative. Okay? This might have been negative 12 and then your solution would be positive 4. That doesn't change anything. None of the addition or subtraction before you get to this point changes anything. This is the very last step. If you have to divide by a negative coefficient, and don't delay in doing this, make this one fluid move. Divide by a negative coefficient, flip the symbol. Okay. So if you have a negative coefficient, then you flip the symbol. And that will then make it true. Less than negative 4 would be 0, for example. And of course, negative 3 times 0 is 0. Well, hold on. Less than, no. 0 is greater than, so that would make it false. Less than negative 4 would be, say, like negative 10, which gives us positive 30, greater than 12, and that's true. Okay. So that will make this true. Okay. So your rule, the only difference from the general strategy for equations, okay, is that your last step, so you don't even have to worry about this early on. You just do things, positive, negative numbers, general strategy, adding, subtracting both sides, killing fractions, whatever. Your last step at the very end, your very last thing you do is when you're dividing away your coefficient. So when you're dividing your coefficient, okay, the coefficient of x, okay, when you're dividing your coefficient, if the coefficient is negative, then you must flip the inequality symbol. And do it right away. Don't delay on that. Make it one fluid movement. Okay. Oh, sorry. There you go. Okay. And this, as I mentioned, is required. This is mathematically required. This is the one difference in the general strategy for solving an inequality that is different from the general strategy for solving an equation. Now, the last thing to take into consideration is to always move the variable to the left. You know, from when we solve equations, okay, like here, like for example where we started, oh, this one made sense to move that variable left because it kept it positive. On this one, a lot of people, it made sense to move that variable to the right because that kept it positive on the right. And so whether you get x equals c or c equals x, it doesn't matter. An equal sign is symmetric. You know, you can't flip it over. It looks the same from one direction or the other. Okay? But with inequalities, direction matters. With inequalities, what direction you're pointing makes all the difference in the world. Okay? So even though this is not mathematically required, you can get the right answer without doing this. I tell you that 99% of the time students who don't do this get the wrong answer because of careless mistakes. Not because it's mathematically wrong to not do it, but because when you're dealing with something that the direction it matters, and then so you end up with a number with an inequality symbol and then the x. Remember, you know, another thing is this has to be from left to right. You know, the smallest to the biggest. So if you've got your number on the left and the x on the right, then that's switching the order of, you know, and which way it points down the number line. So you got to flip things back over and then wait, but then do you switch the negative sign? It's asking for trouble. Okay. But if you make a point of always moving this left, so you always have the x on the left and whatever inequality symbol you have and your number, okay, then you will avoid that problem. Okay. So the variable on the left and the constant on the right. No matter if it gives you negative x's, okay? Lots of people want to avoid that when you're doing equations, but with inequalities, don't try to avoid that. Negative x, positive x, it doesn't matter. You divide away a negative x, and you will have to flip the symbol, but you don't have to end up flipping the whole thing back just to write it in interval notation. That's where mistakes get made. Okay? So again, this is not mathematically required. It can be solved without doing this, but it is strongly, based on years of experience, strongly suggested that you do this. Because I'm not exaggerating that most students who refuse to do it get the problems wrong because of careless mistakes, not because they couldn't solve the first part of the problem right. Okay? Good with that? All right. So, let's solve some. So, 6x plus 4 greater than 3x minus 5. And do 2x minus 1 greater than or equal to 3 times x minus 2. Do a fraction on here. Do these two first, and then we'll slide down to the fraction one. 2/3 times x minus 6 less than or equal to 4/5 times x minus 4.
You want us to put it like in that domain form?
Oh, yes, in interval notation. Yes. So when you get to your inequality statement, then put it on a number line and write the inequality statement, the inequalities notation. Sorry, the interval notation. Yes. So yeah, do both. Now your number line, like on the test, you'll be given number lines. But you know, if you're just doing it for yourself for your homework, working, then it doesn't have to fill in every number and be, just make sure it's regular intervals and things are in the right order. Okay, but just like you saw me drawing them earlier, you don't have to mark every number. 0 does not have to be in the middle. Solving it just like it was an equation, though I made a point of moving my variable left. I would have done that anyway because it kept it positive, but even if it wouldn't, I'd still move that variable left. And second, move the constant right. Now I got 3x greater than -9. That's a -9 there. Should I flip my symbol? No. Because that doesn't matter whether this is positive, negative, or the answer is positive, negative. If the coefficient is positive, then you keep it just like it is. Okay. This is a positive coefficient. Okay. So do not flip the symbol.